Logarithmic equations. Logarithmic equations are those equations that contain the variable in the argument of a logarithm. For example, we have the following shown on screen. Are all logarithmic equations, as in all cases the variable is in the argument of a logarithm. There are three main types of logarithmic equations: 1. Equations with a single logarithmic term; 2. Equations with more than one logarithmic term but with the same base; and 3. Equations with more than one logarithmic term with different bases. Let's have a look at each of them. 1. Equations with a single logarithmic term. In these equations, we send the variable out of the logarithm by using the logarithmic to exponential conversion. The general form of such equations is shown in the following on screen. Where x is the variable. Let's try to understand more through a pair of examples. Example 1. Solve the following logarithmic equations. A. Log 3x equals 2. B. Log 5, 2x minus 1, equals 3. C. Log 2, 1 minus 5x, equals 4. Solution 1. We must write all equations in the exponential form. Thus, A. We have the following shown on screen. B. We have the following shown on screen. C. We have the following shown on screen. Two. Equations with more than one logarithmic term but with the same base. In these equations we only have to focus on the arguments to solve them. This means we can disregard the bases during the solution and solely consider the arguments. However, this is completed only after having expressed the equation to a single logarithmic term on either side. Example 2. Solve the following logarithmic equations. A. Log 5, 1 minus 2x, equals log 5 13. B. Log 2, 3 minus 4x, equals log 2, x minus 6. C. Log 3, 3x minus 1, equals 2 log 3 9. Solution 2. A. Since the base is the same in both sides, so the arguments must be as well. Thus, we have the following shown on screen. B. Again, since the base is the same in both sides, so must the arguments be as well. Thus, we have the following shown on screen. C. First, we have to write both sides as logarithms not multiplied by constants. For this, we have to apply the logarithmic property. We have the following shown on screen. Hence, we have the following shown on screen. Now, we can focus only on the argument given that the rest of elements are equal. Thus, we have the following shown on screen. Three. Equations with more than one logarithmic term with different bases. In these equations, the first thing to do is to attempt to write the logarithms with the same base. If this is possible, the equation is solved by using the second method described; otherwise, the result is usually obtained by applying the logarithmic property. We have the following shown on screen. Let's explain this point through a pair of examples. Example 3. Solve the following equations for x. A. 1 over 2 log 2, 3x minus 1, equals log 4, 2x. B. 2 log 5, 1 minus 4x, equals 4 log 25, 3x minus 2. C. Log 2, 2x minus 3, equals log 6 10. Solution 3. A. First, we turn both logarithms at the same base, here, 2. Thus, we have the following shown on screen. Now, we apply the property of logarithms. We have the following shown on screen. Thus, we have the following shown on screen. B. Again, we first turn both logarithms at the same base, here, 2. Thus, we have the following shown on screen. C. This time it is impossible to write the logarithmic terms at the same base. Thus, we have the following shown on screen. Obviously, there are more challenging exponential and logarithmic equations available in various textbooks. Here we have shown only a few of them just for illustration purposes. That is all for lesson 13.2.2, and the end of tutorial 13.2. To continue this chapter, please watch 13.3, Introduction to Modeling Curves Using Logarithms. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.